Let's look at section 1-2, day 2 of our graphical and numeric approach to limits. And we'll complete the notes page for this. It's just a single page, so it should go pretty quickly. I want you to write the equations of the piecewise function pictured to the right. So what I see when I look at this is 3 different functions that I'm going to have to identify. And I think I'll go with this first one first on the left. So I'm looking at this linear function, and I'm going to try and describe that writing an equation. And basically, it looks like we're up 1 over 1 for a slope. So I'm just going to continue this pattern. There's another slope of 1, a slope of 1, and slope of 1. And I notice that the intersects at -5. So I can write my y equals mx plus b, or slope-intercept form of an equation. So over here I have the function name, and I notice I've got 3 slots, 1, 2, 3, to correspond with the 3 different functions I'm seeing. So on the first one, I'm going to write that I've got a slope of -1. So negative x, and then it passed through -5, so negative x minus 5 would be the equation. Y equals negative x minus 5. The constraint for this one, now if I'm going to back off this writing I had done, the constraint looks like, well, it starts at -3, or really it finishes at -3, and it's every x value to the left of that. So when x is smaller than, not equal to, -3, I have a linear function, because everything to the left of -3 is linear. But it does not include the endpoint, so I would not want to put an equal sign underneath that less than sign. Now let's travel on to the parabola that we're looking at. So I know this is a quadratic equation. It has that pattern of going up 1 over 1, up 3 over 1, and then I bet the next move is an up 5, 1, 2, 3, 4, 5 over 1, which really describes a very traditional or kind of the parent graph of a quadratic. So no stretch or compression going on this one. I just have a little shift of my vertex points. So it appears to me that we've got a shift to the left by 1 and down by 6, it appears. So if I write that, I have x plus 1 quantity squared, because it shifted to the left by 1, dropped by 6, and there we have it. It's not stretched or compressed, it's opening upward, so that would be a positive 1 as my lead number in front of the parentheses getting squared. Now, where does this rule take effect? Well, it starts at -3, which is where the other one had left off, and it looks like we finish at 2. So in this region in between here, I have the quadratic function that I'm naming. So I'm going to travel from -3 to 2. So x resides between -3 and less than 2, but because it's a solid point on the 2 would be included in that middle band. All right, now back to a linear function on this end one. Let's pick up what the slope is. Down 1 to the right by 2, so we've got a half going on for a slope. So if I go up 1 and left 2, it's going to be achieving the same slope, and it looks like we intercept at -1. So my y-intercept point is -1. The slope was positive half, so oh, I'm sorry, it's not positive half, is it? I went down. It's -half x minus 1. So they both should have had negative slopes to them. And indeed, when we wrote them, it turned out that way. So we've got our piecewise function identified, except I didn't do this yet. X has to be greater than 2. So on this final band, it looks like, you know, the work begins. So in this band, this region of x values, when x is greater than 2, we've got the linear function. All right. Cool. Ooh, undo that, baby. Here's what I want. I want to erase this. Next, let's slide down. Use the equations that you just wrote to find each of the following limits and then confirm your results based on the graph. So, as I move into 2 from the right side, I would be in, so I'm just going to be slightly bigger than 2. Well, on this one, on the middle function, it's when it's equal to 2. So I really need to point myself into this band of functions where it was greater than 2. So I'm looking at negative 1/2 x minus 1, and we'll confirm our results. If I put in a value of 2 into that, I'd have negative 1/2 times 2 minus 1. It looks like we should have an answer of negative 2, just doing a simple substitution of the value 2. And if I come over to my graph, when I come into 2 from the right side, so I'm coming into 2 from the right side, if I follow my graph, it indeed is at a height of 2. So, I'm sorry, a height of negative 2. So, negative 2 should be the answer. What about the limit as I come into 2? Well, this gets a little tricky. If I only had the equations to go off of, I really have the left side of 2 and the right side of 2, this being the right side of 2, this being the left side of 2. So I would have to play with each of these equations and see, does the left agree with the right? So if I plugged in, if I looked at the limit as x approaches 2 from the left side, well, then I'm in the middle band, and I'm going to follow the x plus 1 quantity squared minus 6 function. If I plug 2 into that, I get 3. 3 squared is 9. 9 minus 6 says it should be a height of 3. And indeed, that's what we see. If we come into 2 from the left side, it ends up at a height of 3. If I look at the limit from the right side, which is the correct way to look at these, then I'm into this field where I'm greater than 2, so I want to follow the rule negative 1/2 x minus 1. If I substitute 2 into that, I'm going to have negative 1 minus 1. We're at negative 2, which agrees with 2 from the right on our first work. So what I need to analyze is from the left and the right, do those numbers agree? Well, from the left we had a 3, from the right we had a 2. They disagree, and therefore the limit does not exist at 2. And it's quite easy to see if we look at the graphical picture. When we are on 2, from the left side we're at a height of 3, and from the right side we are at a height of negative 2, and obviously the limit doesn't exist then. Okay, coming into negative 3 from the left. Negative 3 from the left. What category did that fall in? Well, that's going to be this first rule. So I'm going to be paying attention to this rule because I'm in this category. I want negative 3 coming in from the underside, so where x is smaller than negative 3. So I could plug in, I'm really going to be following then the limit as x approaches negative 3 from the left. I'm going to be following the rule written for that band. And if I plugged in, let's just plug in negative 3, I'd have the opposite of negative 3 minus 5. So I have positive 3 minus 5, so negative 2. Looks like the right quantity. And then if I wanted to check that on the graph, it is at a height of negative 2. Good. So our answer to this one is negative 2, and for the reasons that we concluded. Coming into negative 3 from the right side. Well, if I come into negative 3 from the right side, the rule that I need then is where x is a little bit larger than negative 3 but less than 2. So now I'm going to point myself in the band that was the middle, right? And looking at the graph here, we're coming into, what do we say, negative 3 from the right. So negative 3 from the right is approaching from this. That means I'm traveling this direction. I should end up with a height of negative 2. And if I put it in, so the limit, let's check it out algebraically. I'd have x plus 1 quantity squared minus 6. Throw in your negative 3. I'd have negative 3 plus 1 gives me negative 2. Square that. I'm at 4. This ends up being 4 minus 6. So we're at negative 2. Very good. -7. Find the limit when x approaches -7. Well, -7 is smaller than -3, so now I'm back to this area, and I'll follow that rule because I fall into this category where x is less than -3. That means the rule that we're following is this. I should put a limit in front of that. The limit as x approaches -7 of the function f of x means that I'm going to follow this rule. Plug in -7. I have the opposite of -7 minus 5 makes +7 minus 5. Should be a height of 2. Validate it. Let's look at what's happening. -7, and I'm coming into it from the left side, I believe. Yep. Or we were just -7. So then we really need to check left and right side of it, but it has a height of +2. Answer was +2. And our final one here is what's happening at -1. When x approaches -1. When x approaches -1, which of these 3 rules must we follow? You are right, we want to follow this middle one because -1 falls in between there. Let's do the work. We put in -1, we get out 0 minus 6. This looks like it will be -6. Let's validate it on our graph. Here I'm coming into -1 from the left and the right. From the left, I'm getting -6. From the right, I'm getting -6. Answer is -6 because the left and the right agree. All right, that was a lot of work. The table below contains a lot of values for an exponential function. Use the table to find the limits. And it looks like, this thing, we're really high when we're at a negative value, and then it's coming down into 1 as we go to the right. So, what is the limit as x approaches -infinity? As I approach -infinity, I noticed that the trend was, I'm just going to kind of picture this thing. So let's just say we've got -9 over here and +9 over here. When I'm at +9, I'm at a height of 1. Let's just call this a height of 1. And when I'm at -9, I'm sky high. So it appears that perhaps, we're coming into it around here. I needed to be kind of a little bit higher than 1 there, but picture's close enough. As I approach -infinity, so I'm way out here to the left, I'm going to be sky high. This will be +infinity. You also could say the function or the limit does not exist here because infinity is not a number. However, by indicating infinity, I'm giving a little bit more information about the function. So let's just put in +infinity. What happens as we approach -3? Well, as I'm approaching -3, it looks like this function is coming down from 33 to 9 and then into 3, but we're really interested in that region, so our answer will be 9. As we approach 1, continuous function, I know exponential functions are continuous from the left and the right, it's going to be 1.5, and as I approach infinity, well, now I'm going to be going further to the right than this, but I noticed how this graph slows down. The height is slowing down, and it looks like it probably will settle around 1, so I'm just going to guess 1. And that's indicated, too, as we kind of sketched out our graph. As we're way out here in infinity, we're going to assume that this levels off, kind of approaches the asymptote of 1, so our answer is 1. And there we have it. So homework will be tomorrow. We'll start on the back side of this notes page, and you may do the homework in class. So just have your notes completed and see you in class.